Hi everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be learning about nuclear fission for GCSE Physics. If you enjoy this video and you would like more content like this, feel free to give it a thumbs up, share the video, and also subscribe to join this amazing community. Thank you so much in advance. So let's get started. Let's talk about this idea of nuclear fission with a real world example. And unfortunately, this was more of a disaster than anything else. It was a situation that occurred in Ukraine in 1986 in a place called Chernobyl. And this is quite a well-known, well-documented disaster where nuclear reactions essentially went wrong. So the situation was as follows. The nuclear power plant in Chernobyl essentially had lots of chain reactions occurring, and there was an issue with reactor 4, which was a part of the industrial process, and it spiraled out of control, causing huge amounts of nuclear waste to be widespread across the area and into and across Europe as well. Unfortunately, a lot of lives were lost as a result of this terrible disaster, but a lot of learning has come from it as well, where we can see the impact of nuclear energy, whether it's good or bad, as we still use nuclear energy today. In fact, 15% of the world's electricity comes from nuclear energy. So there is controversy regarding this as a method of releasing energy and generating electricity, because of the disaster that had occurred in 1986. However, obviously, with everything, there are also positives to it where we can actually create and generate electricity from the energy that is released. And there is a huge amount of energy that can be released. But it's about being mindful of how we use this moving forward. So in terms of the atom, remember we have electron shells that contain electrons. Sometimes these are called electron orbitals. The outer shell sometimes is called valence electron shell. And that's where a lot of the reactivity comes from when we talk about electrons being donated or accepted or shared, in the case of covalent bonding, that is. But today's main focus is actually at the center of the atom, where the protons and the neutrons are found. So the protons are positively charged subatomic particles. They have a mass of 1. Neutrons are also a subatomic particle. They have a mass of 1, but they have neutral charge. And whenever we're speaking about nuclear fission, one of the main errors students come across is referring to the atom, whereas we're mainly referring to the nucleus, or if we're talking about many, we're talking about the nuclei. So what exactly is nuclear fission? Well, the first thing you need to know is that a neutron is hit at high speed. It's fired towards the nucleus of an atom. And specifically, the two atoms we're talking about is uranium-235 and plutonium-239. The numbers are just referring to the atomic mass, by the way, which is where the number of protons and neutrons come from. And if you'd like more information about radioactivity, if you want to learn more about the atom in general, I have loads and loads of videos on this topic and on similar topics as well. So feel free to have a look on playlists. I'll link some stuff for you guys, and also subscribe if you haven't as well already. So once we hit the neutron to the nucleus, this causes the nucleus to actually split, and 2 daughter nuclei are released and created as a result. And this releases a huge amount of energy, which we then can harness, and also in its entirety as a result, neutrons are also emitted as well. And this is where things get interesting, because the neutron, when it gets released as a result of this fission reaction, those neutrons go on to then hit further nuclei and cause more nuclei to separate, and more daughter nuclei to form, and energy to be released, and more neutrons to form, and the cycle continues. So this is very much like a snowballing effect, almost like a domino effect. If you hit one domino, it hits all of them as they go down. And we refer to this idea as a chain reaction. So this is why this happens. It's because of those neutrons being released each time along with the daughter nuclei. So we can use this, and it's an ongoing process. So control rods are used to essentially absorb excess neutrons, and this can slow down the chain reaction, because obviously if we have one neutron that's hit and fired to a nucleus, it can release 2 daughter nuclei and a neutron as well, and that neutron goes on to hit more nuclei, and so on and so on. Before you know it, it can become extremely out of hand, which is what happened unfortunately in the case of Chernobyl, as I mentioned earlier. And those control rods are simply there to absorb the excess neutrons, essentially to control how fast this chain reaction happens. So it's really important to have those in place. So in terms of GCSE, there's some exam questions that can link to this topic, and you'll be asked to explain what a chain reaction means potentially. You might be asked to label an atom, but also more higher end questions which are worth 6 marks are evaluate questions. So one question could be evaluate the risk and benefit of using nuclear power. So evaluate, if you ever see this question, command word, essentially you're looking to give benefits and obviously negatives as well. So things that are good about it, things that are not so good about it, and the risks associated. So some of those things could include, as a benefit, that actually it releases a lot of low carbon emissions compared to, say, fossil fuels, which we know release a huge amount of CO2 emissions. We can say that it's incredibly reliable for electricity generation because it's not, say, weather dependent as compared to, say, solar panels or perhaps wind turbines. You can also say it has a high energy output as well because of that chain reaction. It's a continuous process. Some of the risks, though, obviously, as we mentioned, radioactive waste is one of those risks, and it can cause deaths. It can cause ionizing radiation, leading to things like cancer, so illness, sickness, that sort of thing. It can lead to widespread accidents, i.e., quoting the idea of Chernobyl. And also, it can be expensive because if you're having to build a nuclear power plant, you obviously have to implement a lot of those safety measures, the control rods, the personal protective equipment that people need to wear when they're in that operating space, and also afterwards. So let's say we have a nuclear reactor and later on down the line, several decades later, we want to stop that nuclear power plant and actually decommission it. Well, we need to make sure that it's safely done, so we don't just leave nuclear waste and nuclear reactants just left just instead of actually doing anything about it. We have to decommission it so it's safe for people who live around that area as well. And that's it from me today. Thank you so much for your time. I hope you enjoyed this video and you learned something new. Like I say, if you haven't already subscribed, please do. I've been the GCSE science teacher and you have been curious. If you'd like more videos from me, I have loads and loads of videos down in the description box. I also have some playlists as well linked here for you, so feel free to check them out. In the meantime, have a great day and I'll catch you in the next one. Take care.